What? Stabbing an adult means hurt more than a shot.
He starts tearing up.
I'd be ready.
All right, so writing and graphing inequalities, which has nothing to do with the flu shot, right?
No.
No. So we're going to write inequalities from words, decide if answers are possibly solutions, and then graph the answers. Because we're going to have inequalities or situations like x is greater than 5. So there's lots of numbers that exist that are greater than 5, right? There's 5, there's 6, there's 7, there's 8, there's lots and lots and lots of numbers that are greater than 5. So instead of you having to list all of those possible answers, we use graphs to show, like, hey, start at 5 and just keep going to the right. And use all of those numbers. They can all possibly be answers. Because us mathematicians, we like to use the shorter way of doing things. All right, so do you remember the symbols for inequalities? Do you remember what they look like? Do you remember this bad boy?
Oh, it's like the equal sign with a line through it.
Yeah, there's that one, which is greater than, right?
Equal.
There's the less than.
Less than. Equal to.
Equal
Yeah. There's those 4, right? So we call this one the greater than.
Does it matter?
It does matter. So the greater than, because normally we're, just like we read in regular language, we read from left to right when we're talking about math. So when I look at that, that's telling me the number on the left is greater than the number on the right. So then the next one, this is a less than. The easiest way for you to remember which one's less than is see how the less than kind of looks like an L.
Oh, yeah.
It's like, well, if you tip your head a little bit, it looks like an L. That's how you know it's the less than.
Oh.
Then we have greater than.
Or equal to.
Yeah. And less than or equal to. So since we're going to write these as words, there's also other words that we can use to describe these. So their mathematical names are greater than, less than, greater than or equal to, or less than or equal to. But when we're just talking regular language to each other, we don't always use the most mathematical idea or the correct vocab word. So if I'm saying something is greater than, I can also say more than. So sometimes, like if I'm just kind of being casual, I could say x is more than 5. It means the same thing as x is greater than 5. So I could say, instead of less than, I could say fewer than. Right? Means the same thing. It's just a synonym. Synonym, not synonym. Not has nothing to do with cinnamon. Synonym for less than. It's the other two that get a little bit trickier. So greater than or equal to, I can also say is at least. At least. So greater than or equal to 5, I could also say at least 5. Because if you have to be at least 5 to come to school, you could be 5, you could be 6, you could be 7. You can be any number greater than or equal to 5. So you can be at least 5. I can also say no less than. No less than. So in order to come to school, you can be no less than 5. You have to be 5 in order to come to school. For less than or equal to, I could say things like at most. So if you're going to order off the kids menu, you can be at most 12. So anyone younger than 12 can order off the kids menu. Anyone who is 12 can order off the kids menu. But if you're more than 12, then you can't order off the kids menu. So at most 12. Or no more than. So you can be no more than 12 if you're going to order off the kids menu. So all of those phrases mean the same thing as those symbols. So what we're going to do is we're going to take the phrases and turn them into mathematical symbols because we'd rather use symbols than words, especially if eventually we're going to solve these bad boys.
Words better.
All right, you ready? So I can give you an example of something like a number W minus 3.5 is less than or equal to negative 2. So these are what the first couple of problems on your classwork are going to look like. A number W minus 3.5 is less than or equal to negative 2, and they want us to write it in math symbols without words. So the first thing I do is I go and I read this and I say, okay, I see a number W. W. So I know I can write W as a symbol, right? A number W can just become a W. Minus, well, that one's pretty straightforward, right? Minus becomes a minus sign. 3.5. I know that math symbol too, 3.5. And now I got is less than or equal to. Is less than or equal to. But I remember from my chart, less than or equal to is just a little alligator where the mouth is kind of facing away. And then all that's left is the negative 2. So negative 2. So if I wanted to rewrite that as words, all I do is I go through the words step by step, and I just take each word and turn it into a mathematical symbol in the order that I see them. Not too bad? What about the second one? Can you do the second one? A number B is fewer than 30.4. A number B is fewer than 30.4. Good thing I have that chart that tells me what all those key phrases mean, which symbol I should use for those key phrases. So when I read this, I see a number B. All right, so I'm going to change that to a B. Is fewer than. Which symbol is fewer than?
Alligator that makes an L.
Yeah, it's our less than sign, right? Faces away. Less than. And then all that's left is the 30.4, right? Done. That was all they wanted me to do. No more words, just math symbols.
Yeah, that was easy.
Not bad, right?
For now.
What if we spice it up? What if we said 3 is no more than a number n plus 5? So a little bit more going on, but still the same idea. We can go through and just kind of pick out piece by piece what each thing means. 3 is no more than a number n plus 5. So the first thing I noticed right off the bat is they wrote out the word 3. So I'm going to write the number 3. Then I'm going to go back and look, and I see it says, is no more than. is no more than. Which symbol did that represent?
I'll give it as make it out like it's wrong now.
No more than. So that's our less than symbol.
Wait,
Less than or equal to. Good. Less than or equal to a number n. Ooh, plus. Well, gee, that's an easy word to write, right? Plus 5. I've run out of words. I've run out of words, so I am done. How do you feel about the second one that you do?
See that? I just want to give up immediately.
Because the fraction?
Yep.
Okay. Fraction's a little scary, but we're writing it as symbols. Is the fraction already a math symbol? Yeah, so you're just bringing it down, right? You're just starting with a negative 7/10. They already wrote it as a math symbol for you. Is at least twice a number k minus 4. So take it piece at piece. Is at least.
At least. Greater than or equal to.
Yes. And if I wasn't sure, I go back to my chart from the beginning of my notes and I look to see where I wrote down at least.
And then minus 4.
Twice a number.
Oh, I didn't say twice number.
So what do I do with that twice?
so 2 in parentheses.
It's a 2, right? 2. Twice a number k, right? So 2k. Yep. The minus is a minus. And then I've got a 4.
Yeah.
So now I would know to use a parenthesis if they use the word quantity. Yeah. The word quantity tells me to start that open parenthesis. So if I just want twice a number, I'm just finding 2k's. Not bad? So on your classwork, there's going to be a couple that are going to give you the words. You're going to give me the symbols. And you guys are going to crush that part? Beautiful. All right, so the next part of your classwork asks you to find the solution or to determine if a number is in the solution set. So now we were saying that absolute values can have lots of numbers that go with, or not absolute values, inequalities can have lots of numbers that go with them because we're saying x is greater than 5. So that's a lot of numbers. So we're deciding, instead of just calling it a solution, which is one answer, we have a solution set, so we have a whole group of answers. So this is a group of answers. Group of answers, and it might be something like, for example, x is greater than 5 are all the numbers bigger than 5. So 6 could be a solution, 7 could be a solution, 100 could be a solution, 9,000 could be a solution. I can keep going bigger and bigger and bigger. All of those could be solutions. But numbers smaller than 5 are not solutions. So we're deciding if it's a possible solution or it's not a solution. The way we write that is I give you something like this big giant thing where I say x plus 5 is greater than or equal to 2. Decide if x minus 6 is my solution, or x equals negative 6 is my solution. So they want to know, is negative 6 a possible answer to this inequality? Does that make this inequality true? So for us to solve this, all we're going to do is take this negative 6, and we're going to plug it in where x is, and see if we get a true statement. So where I had my x, I'm going to replace it with a negative 6. I'm going to keep everything else exactly the same. So I just replace my x with a -6. And then I'm going to do any simplification that I can. Do any math I can. Like -6 plus 5. -1, right? I'm going to bring down.
Is less than 2.
-1 is greater than or equal to 2. Is that a true statement? No, it's not true, right? -1 is definitely not bigger than 2. So because this is not true, it's not true. So x equals -6 is not a solution. In order for it to be a solution, I need to get a true statement there. So if it's not true, it's not a solution. If it is true, it is a solution. So any of those that are asking you to decide if it's a solution, you're just plugging it in and seeing if it's true. What would you do for the second one?
Plug in.
You're going to plug in that -8, right? You're going to take -8, you're going to plug it in for x. When you do that, you get -8 plus 5 is greater than or equal to 2. Do -8 plus 5 gives you -3 is greater than or equal to 2. Is that true? No, right? -3 is definitely not greater than 2.
Negative number 2.
Not a solution. Oh boy. What the heck happened there? Not a solution. So far, you're going to crush rewriting them in math symbols, and you're going to be awesome at plugging in and checking if it's a solution.
Oh, yeah, this is not hard.
Wait,
Yeah.
Do you always have to plug it in and check
Yeah.
the solution?
Only if it's asking you. So only if it asks you if it's a solution. All right, here's the last thing you're going to be asked to do. We're going to take that same chart. So if you want to add back to your original chart, you can. If you don't want to redraw yourself a new one. And we're going to take our same symbols. We had our greater than, our less than, our greater than or equal to, and our less than or equal to. And when we go to graph these, we're going to use different symbols to show different notation. Because just like I use a different little arrow to show whether it's greater than or less than, I need to know if the number is being included in the answer or not being included. So when I go to do this, I'm going to either use an open circle or I'm going to shade in the circle. You remember that a little bit from last year?
Oh, yeah.
Maybe.
Whatever level ones.
All right, so we're using less than. Is that greater than? So I have two options for circles. I have an open circle and I have a closed circle. My open circle says I can get really, really close to a number, but that actual number that I'm circling is not included in my solution. So that's our things like x is greater than 5. So numbers that are greater than 5 don't include 5, right? X is less than 5 doesn't include 5. So when I'm talking about those numbers, when I graph those, I go in and I put what's called an open circle. And the way I show that is it's a circle that I don't shade the inside in. I leave it open in the middle. So it's kind of just like I draw a circle and I move on. This is an open circle. And I do this for greater than and for less than. The reason I do this is because I want to say, okay, I can get all these numbers, but I can't actually have the number that I'm circling. So if I'm greater than 5, and I want it to be super, super technical, a number greater than 5 could be 5.00001. or 5.00002, right? There's lots of numbers greater than 5. So the reason I don't want to just color in 6 and say everything bigger than 6 is because there's lots of numbers that I can include in there. But I want to show that I'm not actually including 5 exactly. Whereas if I have a greater than or equal to or a less than or equal to, these get closed circles. And a closed circle, I color all the way in.
So it's like a big period.
Exactly. Closed circle. And the reason I'm going to do this is because I'm going to shade all of my possible answers on the number line. So when I color in that closed circle, I'm shading in the number that I'm actually circling, and I'm including that in my answer. So let's see this with some actual numbers. Let's take x is less than or equal to 3. I'm going to graph x is less than or equal to 3. So the first thing I'm going to do is I'm going to draw my number line. And now the reason I'm drawing a number line to give my answers is because think about all the numbers that are less than 3. I'm not going to sit there for 100 years and be like, okay, 3, 2, 1, 0, -1, -2, and just keep going. I could list them forever. So instead of having to list them, I just draw a little graph that shows all my possible answers. I like to put the number I'm using right in the middle. And then I just kind of, to help myself figure out which way I'm going to shade, I put a couple more numbers on there. Remember, my number line always goes in order from smallest to biggest. And then I say, okay, since this is a less than or equal to, really the only part that I'm looking for is to see if it's equal to or not. Since it's an equal to, what kind of circle do I want to use?
Closed.
Closed, right? So I go back to 3, and I'm going to be really dramatic with my closed circle on 3.
Well, you don't have to put it there, right? You could put it further,
What do you mean?
like it's greater than or equal to.
It's less than or equal to 3, right?
Oh,
So you want to put it right on whatever number is in your inequality, that's the number you want to put the dot on, the circle on. Then I want numbers that are less than 3, right?
oh, well, yeah. So you could do anything.
So I want all the numbers like 2 and 1, right? I want all those numbers to the left. Those are all my possible answers. So to show that those are my possible answers, I go in and I shade in my number line. I darken it up on the side where my possible answers are. And that's all I have to do to show that all of my answers are numbers 3 or smaller. A good hint, too, is if you look at the inequality, because the x comes first, and this is only a shortcut if the x is first. So since it says x is less than or equal to 3, I can look at the way that the inequality is pointing as like a little arrow. So if I look at this inequality, it's pointing to the left, so then I shaded to the left. That only works if the x value is first. So it's just a kind of a hint. So see how in the next one the x doesn't come first? So it's going to be opposite. I have 2 options here. I can just graph it the way it is and kind of think about it while I'm graphing it, or personally I like the x to come first. So if I'm going to change this so that the x is first, I flip everything around. So 2 is less than or equal to x is the same thing as saying x is greater than or equal to 2. And see how when I flipped it, the point over here still pointed at the 2. So even though I flip-flopped the variables, I still made sure that my inequality pointed at the same number. It still pointed at the 2 like it did before. And now I can graph this exactly the same way I was graphing the other one. Draw my number line.
But it goes the opposite way, right?
But it's going to go the opposite way, right? Because now we're talking about numbers bigger than 2. So I've got 2, 3, 4. Let's see, I've got 1, 0. Do I want to use an open circle or a closed circle? Close. And then it's numbers greater than 2, which is everything to the right. So I shade to the right. I want to make sure that when I'm shading, it's obvious where I'm shading. And then I'm done. I put my circle down, I shaded, that's all I needed to do. You try the other two. Can you do the other two? B is greater than -8. And 1.4 is greater than G.
If you want to see how you flip it stationary, would it still be facing G and facing the and just facing G?
Yes, so it's point at G. So, well, it doesn't matter which way the line goes.
It does, because the line tells me which numbers I'm including. So if this is saying x is greater than 2. I'm going backwards. That's why when I do this one, I rewrote it as 3. So the x came first. Because like when I say to you, 2 is less than x, it's kind of confusing, right? It's easier to figure out that x is bigger or smaller than that number. So I always flip it around. But this is saying x is greater than 2. Which I don't want to shade over here because it's 0 and numbers is greater than 2. No, I want to shade the numbers that are.
Okay, so I'm confused with the sign of the same and this one's going this way.
Right, so the signs are the same, but see how the x's are on different sides?
Yeah.
So I always put the x first before I ground.
So whatever way the X is on the line is done. Well,
Not necessarily, whatever way that, if the x comes first, whatever way the arrow is pointing, the line is done. So this one, in order to do it, I had to rewrite it first, I flipped it all around. So I wrote the x first, which then, because I flipped the x over here, I had to flip the sign to face the other way.
Oh,
On the two. And that is because it's pointing this way, and she. What do we get for the first one? Drew a line, right? You put a -8 on it. What's a number bigger than -8?
7.
-7, right? -9 is smaller. Open circle or closed circle? Open.
Oh, I just wasted time doing that. You don't have to go in order, right? I was going in like numerical order.
Yeah, you gotta go in numerical order.
I mean, I was like skipping numbers, I'm assuming, right?
like I just did -1, -2, -3, all the way down to -8. See,
Oh, you did a whole bunch of numbers? Yeah, you don't have to do that.
All of them.
You'll be there for a while if we have an answer of like 60. Which way do I shade, left or right?
right?
To the right. I want numbers greater than, I want B to be greater than -8. So to the right. Ooh, what about the next one? Is that ready to graph? Not really, right? It's backwards. Let's flip it around. So if I switch the G, I noticed the inequality is pointing at the G, so I still want it to point at the G. And then I put my 1.4. So I have G is less than 1.4. I go in, I draw my line.
Good afternoon, Titans. Just a reminder that tomorrow continues our week of respect. We are promoting to acceptance of diversity and individuality and trying to understand, all of us are different, but that doesn't mean that we shouldn't accept everyone. Tomorrow, the activity is to team up against bullying, and all of you count. So wear your favorite sports jersey or t-shirt to school tomorrow. And that could even be supporting our Titans, of course. The challenge of the day would be to text, tweet, or snap a positive message to a family member or friend. So please remember to do that. Just a little hello with a positive message can go a really long way for someone. We never know what someone's going through. So, just send someone a positive message, and you're doing your part to promote respect amongst all of us. So have a great day. Mr. Folks's TV team will remind you of this again tomorrow, but I just wanted to tell you guys to make sure you wear your sports jersey. Any employee that wants to get their flu shot, please go down to the nurse's office, as soon as possible, as soon as the bell rings. Please head down to the nurse's office to get your flu shot. Thank you.
You didn't say employee.
All right, and open or close circle?
Open.
Open. Which way do I shade? Left. Yay.
Wait, so that says 1 and then it's 1.4 automatically?
Yeah, I just